Welcome friends, we have dy dx equals y cosine x over 1 plus y, and we have y of 0 equals 1 that goes to solve this differential equation. We can do this by separation of variables. So just imagine cross multiplication would give you 1 plus y dy, and on the right side we would have, let's see, y cosine x and then dx. Then the y needs to still be moved over, so you can say y 1 plus y divided by y dy is equal to cosine x dx. Now the y's are on the left and the x's on the right. So the variables have been separated. Now you can break this up into 1 over y plus y divided by y, which is 1, and then dy is equal to cosine x dx. And then anti-differentiate on both sides. So you're going to do the antiderivative of 1 over y plus the 1 dy, and on the right side it's going to be the antiderivative of cosine x dx. All right, now when you antidifferentiate 1 over y, that's just ln of the absolute value of y, plus the antiderivative of 1 is just y, and this is equal to the following. The antiderivative of cosine is sine, and then add this. Notice I have only a single c, so I could call this c1. Let me show you something here. And then c2, and then you could do, for example, something like when you combine them, say c1 minus c2, but then you could just call that a new constant like capital C. So you can just do this without this in the first place. Just do it this way. It'll work out. So just call this C like this, you see? That's all. All right. Get rid of these two. So now let's do this. Apply the initial condition. So we have y of 0 equals 1. That means ln of the absolute value of 1 plus, let's see, 1 is equal to the sine of 0 plus the c there. So you're going to have ln of 1, which is 0, plus 1 is equal to sine of 0, which is 0 plus c. So now that we know that c is 1, we can write the solution as ln of the absolute value of y. I've added the graph here. I'll talk about that in a second. Ln of the absolute value of y plus y is equal to sine of x plus 1. Now look at the graph carefully. This is a graph of this is solution. This is an implicit solution because it's very hard to solve this for y directly. If you look at the graph, so first of all, our initial solution point, that would be this one, 0 for x and y for 1, that's right there. But more than that, notice this graph on the right side has a sine term that just oscillates up and down, but it never gets extreme where, for example, it goes through the x-axis, like down through the x-axis. In other words, that is like saying that y equals 0 is never reached. Therefore, what we can do is we can simplify the solution by writing ln of y without the absolute value bars plus y is equal to sine of x plus 1. That's another way to think about it. Please leave a like if it's been helpful.